Well, good evening and welcome to another edition of Snowflake Dan. Tonight we're going to take a look at an all too common problem, and that is how to deal with data that we've imported from an outside source, especially from either a CSV file or an Excel spreadsheet. And the problems that come along with that when we get numbers that Snowflake doesn't know how to convert to be true numeric values. So what I've got set up here is I've created a table and I put some sample data in it, and I've imported the table, imported the data into a varchar field, which is the best practice of the way to do it, because that way you can ensure that you don't get errors when you're loading the CSV. So even for numeric fields, just bring them into varchar fields to begin with, and then deal with them once you get them in the database. Anyway, so I've created the table, and then I've loaded the data with this insert statement, and we'll come back and look at some of these values in more detail here in just a minute. But let's take a look at the data, which we see right here. And we see that we have 14 records with various flavors of different kinds of formats that could show up in your data. And what I'm going to do is I'm going to take this column that contains the values that should be numbers, and I'm going to sum it. And the reason I'm going to sum it is because since this is a varchar field, Snowflake cannot do a sum on string or text values, right? It has to first convert it to a number before it can sum it. So even though I'm not actually explicitly calling toNumber, I am attempting to do a sum, and so it is going to try to convert it anyway before it can return a result. So when I run that, I'm going to get an error, and it says numeric value 1234 is not recognized, and it was 1, 234. So let's go back and look at the data set one more time. And we can see that that's record number 7 down here that failed. Now, spoiler alert, I'm going to tell you that all 6 of these right here actually worked. We'll step through them and we'll prove that that's the case, but I guess, let's see, where ID is less than or equal to 6. So if I try to sum these first 6 records right here, we'll see that it did indeed return a sum, so it was able to successfully convert each one of those values to a number. So let's take a look at what these numbers were again, and then we'll talk about the problem children that we have coming up here. So the first record just contains a 189, nothing else in there. It's all by itself, just the numerals, and so obviously that shouldn't present a problem converting to a number, and it didn't. The second record contains spaces both before and after the 189, and then it's just the 189. That one also didn't present a problem. So not only did I not have to cast or do a toNumber conversion on it, I also didn't have to pass in a trim. Snowflake handled that as well and got rid of both the leading and the trailing spaces. So record number 3 just contains a dash and a 75, or a negative and a 75, right? So that's negative 75, that one converted. And then record number 4 is the same value as number 3, except with leading spaces. And again, Snowflake trimmed it and did the conversion. Record number 5, 3 period 14, or 3 decimal point 14. And again, that period or decimal point works in numeric values, so that didn't present a problem. And finally, record number 6 had leading zeros on it, and a decimal point also, and Snowflake trimmed off the leading zeros and was able to include this one in the sum. And it would have trimmed off the leading zeros whether I had a period in here or a dot or a decimal point. Either way, it would have trimmed off the leading zeros. So those 6 worked great, but now let's start taking a look at the ones that didn't work so well. And as we've seen already, the 1, 2, 3, 4 with the comma in it didn't work. So what I'm going to do down here is I'm going to change my where clause to say where the ID is not in 7. And the reason I used a not in is because there's going to be more than one of these here. That just happens to be the first one. Okay, and I run it again, and now I get numeric value of 55, comma, and then 3 zeros and a decimal and then 2 more zeros. So 55,000 looks like what we were attempting to get. But again, it's the same problem as the other one, right? It's that comma that's in there that's keeping it from being able to work. So let's exclude that one as well. That's record number 8. So we'll do this again here. And now we get numeric value of $33 is not recognized. So far, Snowflake hasn't liked the comma, and it hasn't liked the $. So let's exclude that record. And I'm going to give you a sneak peek at the next couple of records that are coming up here before we actually try to do the conversion. We have a dash all by itself, and then we have a dash with leading and trailing spaces. Okay, so that's record number 10 right there and record number 11. And you might be wondering, well, why do we have a dash in a field that's supposed to contain numbers? And the reason is, this is actually pretty common, is that if you have people who have formatted the numeric cell with the numeric format of accounting format, that accounting format converts all zeros to be dashes within Excel. And when they save their CSV out of that, those dashes make it into the CSV. So these dashes that show up in here really represent 0. But in this case, we're dealing with it right now just as a dash or with spaces on either end. So I think I probably already given away that these are also going to error. But we'll do them one at a time. So we see right here, numeric value of dash is not recognized, so we'll exclude that one. We'll leave number 11 in. The one with 11 is the one that had the leading and trailing spaces. And now we get this error. Notice it's exactly the same error message as the one before it. So even though the values are different because 11 has the leading and trailing spaces, the error message came out to be here. And what that's telling us is that Snowflake got halfway through it before it hit the error. It went ahead and did the trim, and it trimmed off the leading spaces, and it trimmed off the trailing spaces and was left just with the dash, and that's when it hit the error when it was trying to do the conversion. And that's why I put both flavors of that in there, because I wanted to demonstrate to you that it actually got halfway through it before it crashed. And now the last 3 that we have here all have parentheses around the number. So let's go ahead and run one of these here. And we'll see numeric value of 1,000 inside of parentheses is not recognized. And again, this is one of those things that comes from the accounting numeric format in Excel. And it's the way that negative numbers are represented in that format. And I put it in here 3 different ways, but I think we already know that 13 would fail just for the comma alone, 14 would fail for the $, and so the parentheses are just additional problems with it. So what are we going to do about these in order to try and fix them? Well, what I'm going to propose to you, one thing that you might consider doing is to use the replace function, right? And the replace function says, here's a field, okay, or here's a value, I should say, okay, and anytime you find this character, then replace it with this character, for example. But the problem is that the replace only allows for one replacement character. So in our case, we already have to replace the comma, plus we have to replace the $, and we're not even getting to the parentheses yet. We'll just talk about these 2 alone by themselves, right? And we would replace each of these with nothing. But now we have to nest one inside the other. And this nesting stuff gets really ugly really quick when you start to do it, and it becomes super hard to work with. I mean, there's just 2 of them right there. So we're replacing the $, with the space, and we're replacing the comma with that. And like I said, these these would work. In fact, let's go ahead and let's just do this really quick on. Nope, I wanted this here, sorry. Okay, so select sum, and then we have our two replaces from numeric load, where ID in, and let's call this against row number 9. And row number 7 and row number 8. And these don't have to be in numerical order here. All right, and we'll see that it does indeed work on all of these. Uh-oh, unexpected, what did I leave off here? I think it probably means I left off a comma, right? Oh gosh, that looks right to me. Well, and here I'm trying to demonstrate something that I didn't even, oh, I see, I left off the opening paren right there. And that means I probably need to put one here too. There we go. The danger of live demos, right? Okay, so it was able to sum those values right there, and it was able to do the conversion. And just as a demonstration, one more time here, instead of doing a sum, let's just take a look and we'll see that it did clean all those up. Imported string. Sometimes I get ahead of myself because I want to show you so much so quickly. Right, so we can see that it did clean up all of those. But again, the problem with this replace is it starts to get really ugly really quick because we've only handled two of the scenarios, and there's still a couple more that we've got to deal with. So what I'm going to suggest that we use instead is a function called translate. And translate, again, will take a field name just like we were talking about before. Okay, but then it takes a list of characters that we would like to have converted or translated to some other character. So let's say, for example, we put in A, B, C, D into our list of characters that we would like to have it translate. Okay, and then in our conversion function, let's just say we put ABC. Okay, and so we have over here, we have 4 characters, and over here we have 3. If any of these 4 characters are encountered, they will be converted to whatever the counterpart character is over here in this one. So if we find a capital A, which is the first character here, it will convert to the first character here, which is a lowercase a. And if we find a B, it will convert to the second character here, which is a lowercase b. But if we find a C, which is the third character, it'll convert to the third character here, which is a lowercase c. Now this fourth one, if it finds a D, it'll come over here and say, oh, well, we don't have a fourth one over here, so there's nothing that this one corresponds to. So this would be translated to nothing at all, and the D's would be removed. Okay, so there you heard the key to what we're going to do. It will remove it if we don't provide a counterpart over here. Let me just show you really quick though. If I put in lowercase d, capital A, capital N, okay, and I select that, we can see that the lowercase d wasn't translated because it does not appear here. This is a case-sensitive string function, right? The uppercase A was found here, and so it was converted to its counterpart lowercase a, and the uppercase N wasn't found here, so it wasn't converted. If I change this lowercase d to an uppercase D, and I run this again, now the D is removed completely because it says, oh, I see, I do have a D here, but I don't have anything to convert it to, so I'll remove it. All right, so the secret of what we want to do here is that we want to take our field and we want to look for any dollar signs and any commas, and we want to convert those to be nothing at all, and those will work. And so I'm going to take this translate. Notice how this is already much shorter than these two replaces that we had up here, right? So we'll put it here for just a moment so you can see them side by side. And we will run this, and oh, because I have field there instead of the name of the field. Let's put that there, Control V, run it. So there you can see that the translate conversion did exactly, excuse me, what the replace conversion was supposed to do. I'll take that cough out later. And so that's a demonstration that it works and does exactly what we want it to do. So this can be a part of our sum up here instead. So I'm going to copy it and put it up here. Boom. And now I'm going to allow records 7, 8, and 9 to be pulled in. We'll just say all records that are less than 10. Let's see, that's a less than right there, are now eligible. So records 1 through 9 can all be included in this sum. And the translate right there will handle my illegal characters. And just to see this again, okay, you can, oh man, I inserted them. Oops, that's all right. Actually, let's just truncate it and reinsert it again, because again, things go wrong on a live demo. I'm always torn as to whether I should remove some of this stuff from the tape or from the video and just leave it in. And oftentimes the feedback I get when I see people, when people watch and they see me make mistakes, they almost feel relieved, because sometimes I help lots of people with queries, and when they see me make mistakes, they're like, "Oh, I thought that only happened to me." And so it's kind of good to let people see that if you're working in databases, you're going to make all these mistakes all the time. It's just part of the way it works, right? So that's typically why I lean toward just going ahead and leaving it in there. But anyway, so we're back to our 14 records here. All right, and what I was going to show you is we have a where clause that has all of these first 9, and they're now acceptable and usable, because now we can get some, and we will not get an error. So now we just have to figure out how we're going to deal with the dash and how we're going to deal with the parentheses. Okay, now the first thing you might wonder is, oh, I just did it again. The first thing you might wonder is, well, why don't I just take out the dashes, right? Those zeros, I could just include them in my translate and remove them completely. The problem is that the dash is actually serving two different functions on some of these numbers right here. So on record number 10 and 11, the dash means 0 or null, right? We don't care about these ones right here. But up here on records number 3 and 4, that dash is important. So we can't just translate out the dash, because we would effectively turn that negative 75 into a positive 75 if we strip it out. So we've got to deal with the dash in a different way than the way that we're dealing with the other ones that we want to strip out. Okay, so let's go back down here, and we'll start here, and we're going to set the value of imported string equal to null, okay, if it happens to be a dash. So I'm going to use a function called null if, and I'll pull it out in a second and show you a little bit more about it, but this effectively is the function right here, okay, and let me just paste it right here for a second, all right, and what it says is that if the value of imported string, okay, is a dash, and we need a closing quote mark there, okay, then forget about that and make the value null instead. And let me put the closing quote mark on this one as well. Okay, so that's going to help us with the one on record number 10 where we had a null. I think, there we go. Let me make sure this still runs, and then we'll take a look at record number 10. Okay. So what I'm going to do now is I'm going to call this only on record number 10 for the moment. And I'm still calling it on the sum. Oops, it didn't stay highlighted. Here we go. So it converted it to null, which is, that's the wrong statement. Sorry, I meant to paste it into my sum up here. Let's get rid of these two so I can. Okay. So the sum now works on, well, I'm not including the number 10 now. ID equals 10. Okay, so the sum is now converting that value, and we see that we're left with a null here. And if I take this back to the one that's looking at the individual value, we see the imported string is a dash, and then we're left with a null on the back side of it. But watch what happens when I deal with number 11. So adding 11 back into 11 is the one that has the spaces on the front and the back. The null if did not resolve that one. So it fixed the one where the dash was by itself, but it did not fix the one where the dash was had spaces on either side of it. And again, that's because the null if no longer matches this string. Now I told you before that Snowflake was stripping off the spaces on the front and the back when it tried to do the conversions, but that's happening well after this null if right here. That conversion to numbers happening after all these translates and all that other stuff. So by the time this is still being evaluated, this null if, the spaces are still there. So what we've really got to do is we've got to manually trim it ourselves like this. And this will trim off all the leading and trailing spaces. And when we do that, now we can see that both of them were left with null. And so I should be able to grab this entire translate right here. And I'll be more careful so I don't keep pasting stuff in the wrong spot. And I can put this whole thing inside of my sum. So let's remove that and paste all that in there. And we'll say where ID is in 10 or 11. So 10 or 11. Okay, and we see that that's summed to null. And if I just say basically where the ID is less than 12, so that's everything except for the very last two that we still have to fix, that we will get a sum out of this now. So the zeros and the dashes have been taken care of, the dollar signs have been taken care of, the comma has been taken care of, and now all we have is that leading parenthesis to deal with here. Okay, and so let's take a look at rows number 12, 13, and 14 and figure out what are we going to do about these right here. Okay, we can use our translate function again if we want to eliminate these parentheses. But again, we have the same problem with these parentheses that we had when we were dealing with the dash, which is the parentheses actually have a meaning to our number that we can't just throw them away. And so in particular, the way I'm going to get around this is I am going to add the closing parenthesis into my list of characters that we will throw away. In other words, we don't care about it. Okay, so it's right in there. And again, this starts to get a little difficult to read because we have commas both inside of the strings and separating the strings, and we have parentheses inside of the strings and, separating the function calls as well. But this function call in this translate right here says we're translating a $, we're translating a comma, and we're translating a closing paren. Any of those characters gets translated to nothing at all. So all of those will get stripped out. And now watch the magic on this one here. Let's put the closing paren, the opening paren as the first character in my translate string. Okay? And then, nope, that's the wrong place. The first character in the translate string is right here, right? $, comma, closing paren. So let's put it right there. And then let's go to the corresponding characters and put a negative sign right there. So if you find an opening paren, and notice this is the first character of this string of characters, then go to the replacement characters and get the first character. So now an opening paren is going to be turned into a negative sign. And a closing paren is still going to get turned into nothing. A $sign will get turned into nothing, and a comma will get turned into nothing. But this translate will allow us to convert this one to a negative sign and preserve our negative values. So let's run that. And we can see that all three of these flavors of -1000, both the one with no formatting other than the parentheses, the one with the comma, the one with the $sign, all got converted to something that can be converted numerically. Now, it was super important. I want to reiterate one more time. It was super important that I put the opening paren as the first character in this string right here. Because if it was not the first character, then there'd be no, if I put it over here as the fourth character, I'd have to have 3 more characters over here in order to match up to the fourth character, because again, they match up positionally here. So it had to be first in order for it to make this work right here. But this works. So now we're able to take this entire translate, come back up to my sum. Okay, there's the sum empty. Stick it in here. We can take away the where clause now because they're all going to work. And we see that we got a sum of the column. So we've effectively handled every single one of those variations with something that looks a little bit ugly at first, especially if you're not as familiar with the translate function as, it's not one of those commonly used functions, but it can be super powerful, as you can see here. And I'm also going to take this off here just so we can see that it translated on the bottom right here. So I want to close with this, okay, which is do not be tempted to use the try-cast function as your way of doing these conversions, okay? Because what try-cast does is it will convert everything that it can to a number, and if it can't convert it, it'll just leave it as null instead. So if we say try-cast and we say our imported string, I need to type in as number. Okay, I also could have put as numeric or as float or whatever, right? But we can see, just like earlier on, the first 6 converted just fine and dandy. Okay, but none of the last ones converted, which means that their impact on the sum would be, they wouldn't be included in the sum, right? So we would have invalid values and we would not have an error. So that's not good. And so the reason that I really, really caution you against using TriCast is it swallows errors that you probably want to know about. In other words, if you have a numeric value that's preventing you from doing the sum because it can't be converted, that's something that you want to know about rather than squashing the error with the TriCast, thinking that you have no errors and then getting a bad sum. So please, as your takeaway from this, please take away that you really should not use TriCast in situations like this where you're importing from CSVs. It has a very limited number of places where I would consider it safe to use. Say, for example, in an order by, you're probably gonna be okay with that because the worst that would happen is some of your records might be in a different order. But anytime where it's going to impact the quality of your data, I would say try to avoid using TriCast. So we're going to wrap this up. That was a half an hour on a topic that seems pretty basic, but I wanted to be complete in the way I explained it. I appreciate you sticking it out through the end. I hope you enjoyed this content. Will continue to work on improving my delivery and also work for more topics that I think could use some additional exploration and help you really learn to write Snowflake SQL inside and out. So that's it for now. This is SQL Dan saying thank you for watching.